What? It's a video picture.
So this is what we're going to do today, guys, independent events. 10-5. And then again, oh yeah, it should be Kelsey back in, right? 10-6, the last one is dependent events, so it's separated into two sections. So if you want to write, just a quick definition that we have up here, two events where event A occurring does not affect the probability of B occurring. Who's more of an English guru than a math? Did I correct Mr. Ronright when I put an A on there? Should that be affect, not defect?
Are you
Yes.
C.
I'm not good on grammar, but I catch something once in a while. So yeah, it says where event A occurring does not affect the probability of B occurring. Does anybody have, just even based on the probability types of examples that we've gone over, two events that we could come up with that would be considered independent events? Colleen, you look like you wanted to answer. What do you think? Just based on, let's just think in terms of things we've looked at, like rolling a die, or flipping a coin, or drawing cards out of a deck. What are two events that would be considered independent? They don't affect each other at all. Or anybody else you want to jump into? Same time. Do you have an example of two events that we could use to that are independent events? Yeah? Flipping a coin maybe like twice? Like if I wanted to do the probability of getting heads and then heads on two consecutive coin tosses, that actually doesn't have an effect on each other, right? What's my probability of getting heads the first time? Yeah, one out of two. How about flipping and getting heads the second time? Yeah, it's the same, right? 1 out of 2, so it didn't change. The first flip didn't affect the second flip. So that would be a case of two independent events. They could be two completely different ideas too here, two completely different events not related. I could toss a coin for one of my events. I want to know the probability of getting heads. What would that be? 1 out of 2, we just did it. And rolling a die and getting a 6. What's my probability of rolling a die just once, a 6-sided die and getting a 6? Yeah, 1 out of 6. And we'll see how to calculate what the probability of having both things turn out that way, getting those results. We'll see how to figure them out here in a second. Or this one too, draw a king out of a deck of cards, replace it, and then draw an ace. So what's my probability of drawing a king, assuming the jokers are out? So I just have 52 cards. What would my probability of drawing a king be? What's that? How many out of 52? How many kings are there today?
4 out.
There you go. 4 out of 52. Or we can reduce that. That's 1 out of 13. But then I replace it. So then what's the probability of drawing an ace with my second draw?
4.
Yeah, the same, right? Because there's 4 aces. So it'd be 1 out of 13 and 1 out of 13. The first one didn't affect the second one because I put the card back. If I would have pulled that card out and left it out, then it would have changed my second probability because how many cards would I have had to draw from if I took that first card and left it out? Yeah, there would only be 51. So actually my probability of getting an ace on that second card would actually bump up. Not a lot, but it would still be a little bit better, slightly better. Or Pauline came up with that example, tossing 2 coins, or 1 coin 2 times. The tosses don't affect each other. I have a 1 out of 2 chance of getting heads or tails on the first toss, and 1 out of 2 getting a heads or tails on the second toss. So how do we think, before I show you, how would we calculate the probability of having both events happen? Like let's use the last one, an easier one, toss 2 coins. How do I figure out what's my probability of getting heads both times? I know individually it's 1 out of 2 and 1 out of 2. How would I calculate that?
Multiply.
Yeah, multiply them together, right? 1/2 times 1/2. So my probability of getting heads on both tosses would be 1 out of 4. If they're independent, that's what you do. The probability of A and B, so both events actually occurring. You just figure out the individual probabilities, A and B. Even if it's the same event, like I said, if it's getting heads twice in a row, my probability of A is 1 out of 2, my probability of B is 1 out of 2. Multiply them together and I get 1 out of 4. one like that, you could even come up with a sample size. When it's a relatively small sample size like that, you could just do that quickly too if you didn't see that. Because I can either get 2 heads, that's one possibility, 2 tails, that's another one, or I could get heads then tails or tails then heads. So I only have 4 possible outcomes for flipping a coin toss. And to get heads both times, that's just 1 out of 4. It's harder to do when the sample size gets bigger, so you want to understand the basic concept here. And again, just in words, if that helps you see that better that way, 2 or more things have to happen, just multiply the probabilities. It says or more, because I could add more events onto the end here. I could say flip a coin 10 times and figure out the probability of getting heads every time or tails every time. Doesn't matter. Obviously, the more events you add on there, the lower your probability is going to be, the less chance you're going to have of getting that. So let's do another example here. Roll 2 dice, and I want to figure out the probability of coming up with a 6 both times. How do we think I would do that? What's that? Yeah, I only had it. 1 roll, my probability would be 1 out of 6. The second roll, probability is also 1 out of 6. I'll just multiply those together, so out of all the possible outcomes, rolling 2 dice, the chances of me getting a 6 and a 6 is just 1 out of 36. I have a really small probability of getting that outcome. And that would be the same for any individual number. If I was going to say if I wanted to find out the 2 both times, it would be 1 out of 36, or 4 both times, that would be 1 out of 36. So let's do one more example. I don't have it written down here, but with cards again. So what would my probability, Ryan, what would my probability of getting a queen both times if I drew a card out? I did replace it. What would my probability be of getting a queen both times be?
Pretty slim.
How many queens are there in the deck? Yeah, 4 out of 52 or 1 out of 13?
Yeah.
And then I put it back so it doesn't change the probability the second time, right? So it's say 4 out of 52 or 1 out of 13, and then what do I do there? So what's my answer going to be? You can do 13 squared. Come on. Yeah, there you go. So again, out of all the possibilities of drawing 2 cards out, I put it back after the first draw. And again, that would be the same probability for any particular card, whether it was king, queen, jack, or 2, 4, 8, whatever we're going to come up with. I'm only going to have a 1 out of 169 chance of getting the same card twice, the same kind of card twice in a row, not the exact same card, regardless of suit. So it could be the 4 of hearts and the 4 of clubs, doesn't matter. Everybody okay with that, or have any questions on what we covered? And the core idea here again is making sure that the events don't have an effect on each other. The first one doesn't have an effect on that second one. You'll see when you can work on the assigned problems here today. Well, you have plenty of time to get started on it too, like a half hour or so here. Plenty of time to get started on that and see some examples, work through some, get some good practice. We have them up there, but they were already up on the sideboard. If you did get started already, one change we did make, guys, make sure you note that if you happen to if you wrote them down but didn't start. It used to be 7 through 26. We took out 4 problems in the middle there. So what's on the board is right. So jot that down, and you can get started on those. Make sure you're working on older assignments too, though. Like I said, get those in. But again, you do it the rest of the hour, so you have like a half hour here to get going.
Hey, hold on. I'll take a picture.
Like nature.